Right? What a paragraph proof was you wrote in a paragraph or sentences reasons for proving something. You had two on the last homework. You said, I know this is true because of this. I know this is true because of this. Therefore, this is true because of this. So on. Yeah. You had a paragraph proof. This is 2-6, which is algebraic proofs. So a lot of people like algebraic proofs better because they think they're a little more straightforward. And with an algebraic proof, we're going to talk about what's called a two-column proof. Okay? A two-column proof and a formal proof are the same thing. How many columns do you think a two-column proof has?
4.
Yep, 4. Right. It's a trick question. No, it has 2, right? Okay. There's 2 columns and a two-column proof. One side is for some statements and one side is for reasons. We'll get to that in just a second. Okay. So, on our reasons for our two-column proof, in algebraic proofs, we oftentimes use these properties of real numbers. So we have to know what these are. Okay, we talked about these a little bit last time. Now, the reflexive property, that says some number or something's equal to itself. A equals A, 10 equals 10, 5 equals 5. Okay, that's called the reflexive property. The symmetric property means you can switch around what's on each side of the equal sign. If A equals B, then B equals A. If 10 plus 3 equals 13, 13 equals 10 plus 3. Okay, that's a symmetric property. Transitive property we will use a lot. One of your problems on the last homework used it. It said if you have 3 things and the first 2 are equal to each other, and the second and third are equal to each other, then the first and the third have to be equal to each other. Okay? If A equals B and B equals C, then A equals C. Okay? We will use those a lot. These other ones you guys have used a bunch before. Okay? The addition and subtraction property of equality, what you add to one side you have to add to the other, or what you subtract from one side you have to subtract to the other. And then the multiplication and division properties. What you multiply to one side to the equal sign you have to do to the other. Same with division. The substitution property, it means if x equals something or if 2 things are equal to each other, you can substitute them in place of each other in an equation. Okay? If x equals 5, I can put in 5 for x. Okay? If a equals b, I can put in b for a. Okay? I can substitute it. And then the distributive property, we know if we have some term being multiplied by a set of parentheses, if we can distribute that term throughout those parentheses to each term and multiply. Okay? So we've done a lot of these before, but now we're going to have to use these reasons to back up our algebra steps. Okay? And these algebraic proofs. All right, I'll keep it there a second. All right, so let's look at a proof, an algebraic proof. Okay? So again, in all proofs, you're given some pieces of information. You want to prove something to be true, right? So here I give you the x plus y equals 60 and the x equals 5. That's the 2 parts of your given. I want you to prove that y equals 55. Okay? So you just solve this algebra problem, but you write steps for everything you do, or write reasons for everything you do. Okay? So for example here, let's make this a 2-column proof, and we're going to talk a little bit more about 2 columns in just a second. I'm going to put my steps on the left side and my reasons on the right side. So just like every other proof we've done, what does every single proof start out with? What do we start writing in every single proof? The given. What's given to us? Every single proof, no matter if it's 2-column, paragraph, flow proofs we get to, we write what's given to us. Well, x plus y equals 60 was given to us, and so was x equals 5, right? That was given as true. Okay? Those pieces of information were both given to us. Now, what did I do from this step to get to this step? Yeah, I substituted in x equals 5 for x, right? So the reason I got that step was by substitution. Because I'm just trying to solve this algebra problem, and now I just have to write reasons for everything I do. Okay? And then finally, I'm trying to solve for y. What do you have to do to both sides of this equal sign to get y equals 55? You have to subtract 5 from both sides, right? So that's the subtraction property. Now we call it the subtraction property of equality, the addition property of equality. You don't have to write of equality every time, right? So that's a algebraic proof. I did algebra steps. I justified everything I did with reasons on the right side. And I proved what they wanted to prove. I proved y equals 55. Okay. That makes sense? Any questions with that? Yes. Yeah. And we're going to talk a little bit more about that in just a second. Okay. So that's what I had there. So in a two-column proof, just like that one, we always write our work or our statements on the left, and we always write our reasons or our justifications on the right, every time. Okay. So in every two-column proof you make, you can make like a big T-chart, right? On the left side, you put your work, and you put your statements, and on the right side, you put your reasons, okay? You use your postulates, your theorems, those properties, okay? And on this side, we put our work in every two-column proof, okay? So, for example, let's say we have this one here. I'm going to make a two-column, okay? Let's go ahead and do this. There's my two-column, okay? In every proof, I always put what's given to me. In this case, this is what's given to me. And it wants me to verify each of the steps I do here in this two-column. I'm going to do every step. I'm going to write what I do to find out what A equals. Now, just like in that activity we did with the other day, it doesn't matter what order you do stuff in, as long as it follows algebraically, as long as you can algebraically do that. So some of you may solve this problem differently than others, but as long as you give correct properties and correct justification over here, that's fine. What's the next step I could do here to start solving for A? I'd say the next step is to use distributive property. So distribute here, you get 10 minus 6A, distribute that negative 4. And again, that's distributive property. That's how I did that. Now, what's something I would do next to start solving this problem? Yeah, I would combine like terms. I have a set here and here, and a set here and here. Now, our reason, there is not a reason that's combined like terms. What we write there instead, well, let's go ahead and simplify it. So I have negative 6A minus 4A is negative 10A, and 10 minus 28 is minus 18. Now, this is very important. We don't have a reason that's combining like terms, because what we actually did here was we substituted negative 10A in place of negative 6A minus 4A. And we substituted negative 18 in the place of 10 minus 28. So when we combine like terms, we call that substitution. Okay? Because we just replaced it with something simpler that's still equivalent. Okay? So you'll never have a reason that's combined like terms. You just call that substitution. Okay? At this point, we want to undo the minus 18 next. So we would add 18 to both sides. So I have negative 10A equals 110. What reason gives me that? Addition property. Yes. Okay, that's all right. Okay. So that's addition property. Finally, I want to undo this negative 10 times A. So I would divide both sides by negative 10. And get A is negative 10. That's by division property. Okay. Sorry, negative 11. Yes, thank you. Negative 11. So there's my proof that A equals negative 11. Okay. I have my steps on the left, my reasons on the right. That's an an algebraic proof. Okay. Again, just remember, when you combine like terms, we call that substitution. You're substituting in something that's still equivalent. Division property. Okay. Because I divided both sides by the same thing. All right. Any questions there?
Can we go over what's going to be on quiz?
The homework did.
Well, I know, but like, refresh my mind.
We're going to keep going over some of this stuff first. All right, so let's look at another one here. Now, one thing I want to show in this, the proof the book did, if it shows substitution property in there, okay? The way we did it wasn't incorrect, but they on each step after they added to both sides, they wrote the addition step, and then they substituted 110 in place of this. And they substituted, does that make sense? Oh, no, let me go back here. Okay. And then when they did the division property, they substituted negative 11 in for this. Okay. My personal preference, I don't care which way you do it as long as your steps are there. But in some of the fill in the blank ones on the book, like it may say what was the last step here after the division property. You would say substitution because you substituted in negative 11 in place of this, and you substituted 1 in place of this. Okay? Their addition property, they actually wrote the addition and then said, when I simplified it, it's substitution. So anytime you have substitution or combining like terms or simplification, you normally write substitution. Okay? But if you write the addition property and just jump to this step, that's fine. Okay? But in some of the fill in the blank proofs, just be aware that you might see that substitution. Okay? All right. I would like us to try this one on a scratch sheet of paper. If you would like some of mine, it's up there in the corner. I want you to try to prove D equals 3 algebraically and justify each step. Okay? So hopefully everybody's first step is at least the same. What's the first step? Right, you write what's given to you. Okay? And what's given to you is that 7D plus 3 divided by 4 equals 6. Okay? From here, your next step is probably the same also. Okay? That you need to undo what's affecting everything on this side of the equal sign, right? This division by 4 is affecting everything. So you need to undo that division by 4 first. So to undo a division by 4, what do you do to both sides? Multiply by 4, okay? So the next one you would have multiplication property. Now, if you actually multiplied and then wrote multiplication property, that's fine. In this example, I'm doing it where you write substitution to simplify each step. Okay. So for example, if here you would have wrote 7D plus 3 equals 24 and then wrote multiplication, that's okay. So at this point, we need to then simplify, since I just wrote the multiplication by 4. That means those divide out, and this becomes 24. So I'm going to put 24 in place of this, and I'm going to put 7D plus 3 in place of this. So in this proof, what property would come next? Substitution, right. Okay. So again, if you had this as number 2 and wrote multiplication property, that's fine if you did this multiplication in one step. Okay. At this point, we have to undo the addition before we undo the multiplication. Remember, we undo the thing to the attach the variable last, multiplication or division last. So I need to subtract both sides by 3. Okay, that's a substitution property, or the subtraction property. Again, if you went ahead and subtracted them and wrote subtraction, that's fine. But in this proof, they wrote the subtraction property, actually wrote out the subtraction, and then simplified it. So we substituted. We substituted 21 in place of this. We substituted 7D in place of this. The last step, of course, we need to undo that multiplication by 7. So we would divide both sides by 7. Okay. And when we divide both sides by 7 there, we're going to substitute just the variable D in place of this, and we're going to substitute 3 in for that. So we prove D equals 3. Okay. That's a proof, an algebraic proof using this equation that D equals 3, justifying each step. Again, if you didn't write the substitution in between and just wrote the multiplication, subtraction, and stuff, that's still acceptable. Okay. Any questions on that algebraic proof? So let's just fill in the missing steps here. Looking at this proof, I'm given this equation. I'm trying to prove n equals 2. What property would be written right here in this proof? Multiplication, right? Multiply both sides by 3. Right. In this one, I have a stop sign. Angle A is 135. Okay? And I know angle A and angle G are the same, or they're congruent. That's what's given to me. I want to prove angle G is 135. Well, that's what's given to me. Now, again, when I talk about measures, when I talk about numbers, that's when we use the equal sign. When you use the congruent symbol, that's when you're talking about the figures. Okay? So I have to change this congruent sign to an equal sign because I want to talk about numbers. Does that make sense? Okay. So when you're talking about numeric values, you need to use the equal sign. So to go from congruent to equal, all you have to do is say, well, the definition of congruency or the definition of congruent angles. Because to be congruent also means to be equal. Okay? So if you have to jump back and forth from congruent to equal, you can go from congruent to equal. We just put the measure in between here because we're talking about numbers. Okay? We can use that by just saying the definition of congruency. So how if angle A is 135 and A is equal to G, okay, how is G 135? What property would go here? Okay. So I have A is equal to 135. Okay. A is equal to G, so therefore G is equal to 135. So I have the first two things are equal to each other. Second, third things are equal to each other. So the first and the third thing are equal to each other. Which one of these? Yeah, that one's transitive, right? So A equals 135, A equals G, therefore G equals 135. Okay? So that one is transitive property. So part of the homework assignment is just given a proof, fill in the missing step. Okay? One more algebraic proof. This is the exact same. Okay, we would always write what's given to us. In this case, you could do multiple things here. You could subtract the 5 over first if you wanted to, then you could use subtraction property. This specific proof wanted to get rid of the division by 3, so it multiplied everything by 3. Okay? Once they did that, they then distributed that 3. Okay? Then they subtracted. Then they simplified, so they substituted. Then they divided both sides by -2. Then they simplified, so they substituted. Okay, so just another proof. Again, this isn't the only way to prove this problem, right? You could have started by subtracting 5 from both sides. Okay? But you get the same result, and both of them are good proofs. All right, and that's the end of algebraic proofs. Okay.